Hello, good evening, everyone. So, I think we have gone through a lot of technologies through these weeks and discussed a range of solar related technologies like solar photovoltaic cells. Then, in these weeks, we are talking about flat plate collectors. So, I'm sure you guys must be enjoying this course and having a good time learning about different technologies of solar. So, uh, should we start? Yeah, I think we should start because already a bunch of time has been passed and uh, other people can join in the meantime. Okay, so, so once again, welcome you all to this live session of NPTEL. This is live session 8 being conducted on 18th of September. Somebody wants to join. Okay, so yeah, I was thinking somebody wants to join. Okay, so welcome you all to this live session 8 of NPTEL. The course name is Solar Energy Engineering and Technology. This is live session 8 being conducted on 18th of September 2023. This course is taught by Professor Pankaj Kalita. He is a professor in IIT Guwahati, and I am Rohit. I am a scholar in IIT Bombay. I will be taking this live session 8. So, this live session is basically to make the course more interactive to the students. So, that's how we have planned this live session. So I will first talking about some concepts and my major focus because most of you guys are getting a lot of difficulties in solving numericals. So my major focus will be in solving numerical questions when I discuss the concepts, and then we will solve the assignment questions of previous year. Okay. So I think that will benefit you guys a lot. Okay. So if there are any queries from previous live session or anything you want to ask, please raise your hand and you can ask it now. Okay, so no queries. So let me start from lecture 20. So that will help you guys. So basically these are the equation which you need to solve this type of question. So it talks about the collector losses. So anything which you study in mechanical or thermal system has to have energy balance. So whatever energy is coming, some of the energy will be absorbed and other energy will be lost. So whatever energy is coming can be represented from here, and whatever it lost can be get from this equation. So one more thing is that this heat loss from the collector is actually some of the heat loss from top, that is this one, and from side and then bottom. Okay, so please remember this equation, it will be helpful in solving the question. And these are loss coefficients. So actually top, bottom and side has actually loss values, and basically this overall loss coefficient is the sum of these individual of loss coefficients. Okay, so generally it's in range of 2 to 10 watt per meter square. This is thermal resistant network. I think this will be very much useful if you want to draw a single or thing out of a complex network. So that will help in that also helps in solving the numericals in a much easier way. So I think I won't go in detail and discuss each and everything how this formula is derived, because professor has very beautifully explained these concepts. So yeah, I will guide you guys, because this formulas are very important, and it's not that these are very big formulas. These are very easy formulas. You can easily remember them. Okay. And there are some correlation for inclined surfaces and Nusselt number correlation. So yeah, for this value, please remember it. There is heat loss coefficient due to wind, that is heat transfer coefficient. So there is a McAdams correlation, that is 5.7 plus 3.8 V. So you can use it to get the value of HW. And another correlation is this. So it doesn't mean that there may be some differences, but these differences are not so uh, very big, not so large, and actually these represent different other conditions. So depending on them, they have developed correlation to evaluate the wind heat transfer coefficient. Okay, bottom loss coefficient is this. So you can get the value of bottom loss coefficient, thermal conductivity of insulation upon thickness of insulation. And you can get the value of side loss coefficient through this. Okay, then there is a numerical. So uh, okay, so what we will do, let's change the value of this and solve a numerical. So let's change this value and solve a numerical to ourselves. So you guys can be more familiar with how numericals can be asked. On the I specifically put a blank slide for you guys so that we can practice questions. So let me instead of writing, let me copy it. So we have got the data. Now we will solve it. Let's change the values. Instead of 6.6, let's make it 8.2. Okay. And any more values we want to change? Let's change the back consideration to 0.45. Okay. Collector back length to 9. Now let us try this question. So whoever is there in the okay, so this is how you can approach this question. So let me show you the approach to this question. So the first thing you can do is to calculate the back loss coefficient UB. Okay. So UB is Ki upon delta. So what is the value of Ki from here? 0.04. So right here 0.04 on. And what is the value of delta here? So so we were planning to solve a numerical and I was trying to explain each and every approach. So what is the value of delta here? Delta is back insulation thickness, that is 0.055. Okay, so divide it now. 0.04 upon 0.055. So this is around 0.727. One more thing is that I am not writing the unit, but unit will be always okay. Now you have successfully evaluated back loss coefficient. Now another thing is that you have to evaluate side loss coefficient. So what is the formula for this? L1 plus L2 to H Ki L1 L2 sorry. So L1 is basically collector bank length. So it's written bank, it's back. Oh, sorry, bank. So 9 plus value of L2 is width. Okay, 2.5. How much is the value of H? The value of H is given. That is collector thickness. Then value of K is given 0.0. Oh, not this 0.04. Divided upon 9 into 2.5 into, and this is edge insulation thickness, that is side insulation, that is 0.02. calculate it. 11.5 into 0.08 into 4. Okay, so I think most of you will be understanding this, how this question is getting approached and how it is getting solved. Okay, so till now, if there are any problems, please write in the chat box. I will try to answer your questions. Okay. Now, third thing, that is the main thing that is being asked in the question. Overall loss coefficient is equal to U top, U bottom or back, and U side. How much was the U top? 8.2. How much was the bottom? 0.727. How much was the side? 0.081. So this is the answer for this question. So you guys could now solve this type of question. This type of question can be in the exam. So you guys can easily approach this question and solve it. Okay. So based on we change the values, we change everything. If you want, I can change everything. And then add sometimes this top loss coefficient will not be given. Maybe back loss coefficient. Okay. Sometimes some other data can be given. So based on the data, you need to apply your mind and think in a structured way so that you can easily solve this question. These questions are actually pretty easy question which you can approach on the first hand. So what I will do, I will keep you guys at this position so you guys can actually solve this question and understand how it has been solved. Okay. Please go through it, and if there are any questions or any doubts you want to ask in this question, please feel free to ask. Somebody wants to join. Okay, so please go through this, and if there are any queries, please feel free to ask. Okay, so did you guys get the question? Or do you want discussion on this topic more? Or do you want to solve more this type of questions? Is it okay? So do you move to the next question or you want so let's solve some let's say this is backlash coefficient. Let's say change the value of this to some other values. So let's say it's not it's 10.2. So what will be the change here? Okay. So it's totally easy. So we change 10.2, 8.2, 10.2. So just couple of, you have calculated this. All these things will remain same. Just write 10.2 here. So that will be 2 plus this. Okay. So that's how these questions are actually solved. So I hope you guys have now a clear concept on this. So okay, so I think we can pass this question and then move to some other question. Okay. So yeah, so what we are talking about this specific energy balance equation. So yeah, whenever you study mechanical or energy based system, like here it's energy based system. How do you know this is an energy based system? Because solar energy is being converted to heat energy. Okay, so make sure there is a law that says energy can neither be created nor be destroyed. So whatever thing is this, it will be acting in an energy balance. Okay, so whatever energy is coming to this flat plate collector, depending on the area, how much energy it grabs from the solar energy, so that will have to be balanced equally. Whatever is lost or whatever is getting transferred to the fluid. Okay, so how do we calculate it? So QU, that is energy captured, area of collector into S, that is S, you can get it from here, that is radiation, into minus UL, that is overall coefficient of loss, UT and B and S, that is some of these, TP and mean temperature of plate, minus TA, that is T ambient to T air. Okay, so this is how the different formulas are there, and then we have different resistances that cover all these things. So that can, you can use it to draw equivalent resistance also. So these are actually very much utilized when you try to calculate the losses that is occurring throughout the, or there is a heat transfer, how much is the heat transfer, what are the different rates of heat transfer. That is what this thermal network actually helps in. uh, what happened? So okay, so yeah, next thing is that key, then you have to study the temperature profile. I don't know what happened. It's on the slides visual. Yeah, it's visible. So then there is a discussion of temperature profile. So I won't go into detail because these are very much so, relation based how these are drawn. So just you can get to know that it vary like this. This is the temperature profile. Then we have something called collector efficiency factor. So collector efficiency factor is the ratio of actual heat collection rate to the useful heat collection rate, which would occur if the collector absorb rate are at temperature T, that is same temperature. So generally its values ranges from zero point 0.8 to 0.95. So similarly there is a collector heat removal factor. So these two definitions can be very important. So whenever uh, you are going for solving assignment questions, so expect these type of questions also. Okay, then we have collector efficiency factor 1D analysis. So yeah, how collector efficiency, basically it's a heat transfer thing. So whatever is this, you have to make an energy balance, then you have to calculate the how much energy is coming in, then what is the energy that is going out. So basically net heat conducted into this element. So if you are taking this element dx of dx, right, so net heat conducted to the element and incident energy absorbed equal to heat lost from the element. So basically, this is the energy balance equation. So net heat conducted into the element. So this is basically a time-bound phenomena with variation of this length also. So you can it can be written as this, then this, and it's energy, and this is minus. So this goes here. ds dy tp minus ta. So uh, then this can go like this. So u will tp minus ta equal to minus s dx dy is got cancelled. Then transfer these things, and this will be like this. Basically rearranging of this, and this is basically question of this form. So if you want a solution, so these are the boundary conditions which can be utilized to solve this equation. Okay, so the general solution comes out to be this one. Differentiate this, put this in that, and then differentiate, and you get this value by solving it. So this is how you solve it. I won't go much into detail of solving it because it will take itself 1 hour to explain all these things. So please watch the lecture, that will be much more helpful. Then you have collection efficiency factor and how it is calculated. So these are basically concepts of fins that is being heat transfer that is being utilized here. So, okay. So these are quite big formulas. So I explain not the basically in subjective exam there can be questions like define collector efficiency and then derive the equation. But generally in MCQ type questions you expect a much easier way, toned down version of you just have to remember the final formulas and try to understand how to solve this question. Okay. We have this question, so we'll solve this question. Okay, so we have two questions here, and then there is transient analysis, which itself is a quite big topic. How the temperature varies with time and space also. So that's how. So let's solve this question. So basically, this is a pretty easy question. Okay, so let's solve this question and then we will move to the. Okay, so what I have done, I changed the values. I changed the value of most of the things so that you guys can approach this question with your confidence. Okay, I want you guys to understand how these questions are solved. So that will help you guys to actually solve this question in a much better way. So first approach is that key try to write down whatever is given in the question. Okay, so first thing is given. What the first thing is given? Overall heat loss coefficient is given. So write it down. Given how much it is given? 7.8. Another thing is that okay, diameter is given. Okay, so di equal to how much? 14 mm, and then outer diameter is 18 mm. 14, outer is 18, and then center to width of tube equal to 12 mm given. How much is the heat transfer coefficient given? So mind it, this is the heat transfer coefficient of fluid. Okay, fluid. Now from the formula you know collector efficiency factor equal to 1 upon W into UL, 1 upon UL, W minus T naught, phi plus D naught. Plus 1 upon pi di into hf. So you know W given, UL given, otherwise you have to calculate the UL also. DO given, DO given, DI also given, pi equal to 3.14. You know, the important thing is that you need to know the phi. So if you know the phi, you can get the value of f. So what is phi? Phi equal to tan h minus d naught upon 2 and w minus d naught upon 2. So put the values, you know everything, you know tan. tan hyperbolic. How much is the m? So for m you need to evaluate it. M equal to underscore overall loss coefficient upon Kp into thermal conductivity of plate into thickness of plate. So how much is thermal conductivity of plate given? It's 7.8. Thermal conductivity of plate is given 450. How much is the thickness of plate given? 0. 0.3. Observable material copper. So this is in mm, so try to convert it in meter. So you will get a value, put this value here, you know every value here, get the value of phi and put the value of phi here. So that's how you will get the collector efficiency factor. So okay, so that will be something around if 0.8 or something. Okay, so I leave it to you guys, so please calculate it. I leave it to you guys so that you guys can easily approach and calculate it. Okay. Okay, so guys, did you solve it? No? Okay, no problem. Solve it again in the house. Then I think we waited along and nobody was able to solve it. So this is you just have to put the values here, guys. You can easily solve it. Okay, so try to solve it. Okay, the answer will be very near to 0.8 or something. Okay, so from here let's move to the assignment questions. So basically, I am focusing more on this numerical questions only because you guys were asking, sir, we were not able to solve the numerical questions, and I really want to discuss only numerical question and to give you guys time so that you guys can solve these questions easily and we can have a great discussion on that. So yeah. So now let's see the assignment question. So yeah, I will go slow on these assignment questions because I want you guys to understand the concepts here. So in a flat plate collector, higher absorbance and low long wavelength emittance can be achieved by choosing a. So it's saying higher absorbance. So there should be something related to orientation which leads to and selective coating also and lower long wavelength. So it's saying absorbance also and lower long wavelength emittance also. So this is 100% with orientation, that is with the location. So correct answer is suitable location. Okay. So yeah, I put a photo of this flat plate collector also. So what happens inside a flat? This is the glazing, that is the glass cover. This is the enclosure. Okay, this wooden box or something which this is not of wooden. This is metallic enclosure, and with insulation also there are insulations. And this is the absorber plate. Okay, this then these are pipes, flow tubes in which this is header pipe. Then these are flow tubes in which the water goes and takes the heat. Then this is a glazing frame. This is inlet water. This is outlet water. Okay, so this is how the flat plate collector works. Top loss coefficient is evaluated by considering dash and dash. So yeah, just we consider this top loss coefficient. So what it was basically convection and re-radiation. Okay. So this is the correct answer. So this is how this is the glass cover, this is the absorber, and this is where the conduction and radiation take place. So it basically shows the distribution of heat. And so I was talking about this energy balance now. Sorry for my spelling mistake. It's energy balance. Okay. So this is how whatever energy is coming, this is how it gets distributed. So let me erase this and please have a look at this. Okay. Please have a look at this. Okay. So you guys could easily understand what was the energy balance that I was talking about. So this picture has been taken from science that research paper itself. So yeah, please go through it. And if there is anything which you want to understand, please ask me. Okay, so I think you guys easily understood the different energy distribution, and then let's move to the next question. So the ratio of actual useful energy gain to the rate of useful energy gain in the entire collector where at fluid inlet temperature in a force the mode is termed as. So I think you guys remember this. This is called collection heat removal factor. So we actually discussed a lot in the previous slides also when I was discussing this heat removal factor. Optimum inclination angle of flat plate radiator for winter season. So mind it, this is saying winter season. So for summer season, then there is winter season. So basically, it's for winter season, it's 5 plus 15. The position of dust on the flat plate collector surface depends on. So it also depends on the material of the cover. Your roughness will be there. Tilt of the collector also. So less tilt, more dust deposition will be there. Frequency of cleaning is also. So all of the above option is. To maximize the output temperature in the liquid flat plate collector, the collector should be connected in. So it should be connected in series. Okay, so we have seen this in the slides also. So for this, the collector should be collected in series. So now similar question we solved. Um, I will solve this question, but please first try this question. Okay. So first try this question, then I will solve this question because this is very easy question, and I want you guys to first try this question. It's a very easy question, and please try it. Then I will solve it. Okay. So I'm giving you 5 minutes. I want you guys to practice more and more numericals. So I want you guys to solve it because it's a quite easy question, a formula based question which you can easily solve. Okay. Let's solve it. Okay. So you have to calculate the overall loss coefficient, that is UL equal to U top plus U back plus U side. Side loss coefficient is given, top loss coefficient is also given. You need to calculate the back loss coefficient, that is Ki 0.04 upon 25. Okay, so yeah, I convert it into. So that's how you get the values. So correct answer is 7.98. Now this is a fin efficiency remove factor for the collector. So I think this question, please try it. This is also this kind of convective heat transfer is given, inductive performance and overloss heat coefficient. Everything is given. So there is a formula for fin efficiency factor. So you can apply and solve it. So try to solve it. Okay. Okay, guys. So yeah, you can easily put these values in the formula and get the answer. The correct answer is 0.944. Okay. Moving to the next question, the correction efficiency factor. So actually, we discussed a lot here. Correction efficiency no formula here. So yeah, just put the formula. I think I solved the question here, na? Collection efficiency factor. This one, this this one was based on collection efficiency factor or something. Yeah, collection efficiency factor. So you use this formula. This is the same formula which same type of numerical which we had solved. So the correct answer will be A, 182. Now heat removal factor. This is also here. I think heat removal factor. Yeah, this one. I think this one or heat. No. This is not the heat removal factor. Uh, this is not the heat removal factor. I think it will be if something in the formula. So heat removal factor is this. So the formula for heat removal factor is also given. You just have to put the values here and just get the answer. So I'm not going to solve it because the time is also less, and I just want you guys to. I just want you guys to try the. Okay, so the this is also a heat removal factor which you needed to calculate. So the correct answer will be answer B. Then this circulating pump has the maximum temperature attained by the plate head. So just balance the equation, whatever is the heat taken, heat loss. So that heat will also be going to the plate. Okay. So with this you can calculate the maximum heat temperature attained by the plate. That is C. Okay, and try this one. This is actually very easy. In the maximum tilt for of a flat plate to grade for maximum insulation is you need to calculate. Okay, so the correct answer is 5 degree. So try to solve this question. These questions are actually easy and you can do it on your own. Okay. So try to solve it. Okay. So this question we discussed also. So have a read and then I will move to next quiz. So again, thank you all for this lovely live session, and I think you guys have learned a lot. So if you have any question, please feel free to ask me. And happy Ganesh Chaturthi. We'll meet at next Monday. Thank you.